Okay, here we are back for more. We need to learn the derivatives of all the inverse trig functions, and there's 6 of them, but really there's just 3. Arcsine and arccosine are basically the same, they differ by a negative. Arctan and arccotan are also differ by a negative. So the derivative of arctan I did in class. Yeah, I did in class on, oh, here comes the baby. On the last day of school, and not a particularly good job, but yeah. And then I posted a video showing how to do it a little bit better, and also we did the derivative of arcsine in that video. The one that's really tricky is the derivative of arc secant, and the calculus is not hard, but the precalculus is hard. Okay, how are we going to do this? Well, okay, let's begin. We just define the curve y equals arc secant x, and or rather, oh yeah, and then we now want to what we now want out of all this is what we want is dy dx. Okay, so what is the derivative of y with respect to x? Okay. I don't know how to differentiate arc secant, so the thing to do is to rewrite it in terms of secant, because I do know how to differentiate secant. So if y is arc secant, then it means that the secant of y is x. Well, this is just great, because I can differentiate both sides of this equation with respect to x, and over here I get that the derivative of secant of something is secant something tan something back inside for the derivative of the something. And the derivative of x, of course, is just 1. Okay, so this is like a 3-minute process, basically. And now I'll multiply by, I guess, like cosine, cotan. If I did that right, yeah. Okay, so great. This is all there is to it. This is not, however, what I want, because I don't want this in terms of y, I want this in terms of x. So now comes the hard part, which is the precalculus part. So the question is, what is the cosine of the arc secant of x, and what is the cotan of the arc secant of x? And okay, this year, school year 2019-2020, we did not take a whole block in Precalc C and review these things, which I do most years. So maybe you know how to do this and maybe not. But the problem is that you got to be really careful, because all right, what does arc secant even look like? Well, secant looks like this. You go from negative pi over 2 to pi over 2.
Well, what's that then?
What's up? Did you say?
I'm talking to the baby.
All right, talking to the baby. So, secant looks like this, and this function, of course, is not 1-to-1. So we have to restrict the domain, and we restrict the domain to be the interval from 0 to pi. And having done that, this is just secant. Now, what does arc secant even look like? Perhaps I should have just started with this. Well, let's see. When I plug 0 into secant, I get 1. So when I plug 1 into secant, I should get 0. As x gets very close to pi over 2, but a little bit less than pi over 2, y goes to infinity. So therefore, on the graph of arc secant, I should expect that as x goes to infinity, oh, I see I've now made a bad mistake here. Y should go to a little bit less than pi over 2. And now, continuing this up here, if I plug pi into secant, I get -1. So when I plug -1 into secant, I get pi. So that's like pi up there. And now if x is a little bit more than pi over 2, y is -infinity. So if x is a little bit, as x goes to negative infinity, y will approach a little bit more than pi over 2. Okay, so this is the graph of secant right here, arcsecant rather, arcsecant x. Okay, and I kind of just noticed that this function has always positive sloped tangent lines. So positive, positive. So I expect the derivative of this thing to be positive always. And what do I learn about the arcsecant function? Well, based on the fact that we've insisted, based on the fact that we restricted the domain to be from 0 to pi, it means that the output of the arcsecant function is always going to be between 0 and pi. And so the range of arcsecant is always something between 0 and pi. Okay, keeping that in mind, I now am going to draw a picture of arcsecant. And the problem is that when I draw a picture of arcsecant, it's hard to even draw the picture without knowing what quadrant to draw it in. And the answer is it depends. If x is positive, then the arcsecant of a positive angle is going to be something between 0 and pi over 2. In other words, a first quadrant angle. But if x is negative, then the arcsecant of something negative is going to be between pi over 2 and pi. In other words, a second quadrant angle. And so even the decision of where to draw the angle requires you to first know whether x is positive or negative. So there's just some casework built into this. Okay. So, well, we're just not scared. We're just do it. If x is positive, then if I want to draw a picture of y equals arcsecant, then I just need to maybe this is the better relationship to try to depict. To draw a picture of arcsecant, I need an angle whose secant is x. So this is my first quadrant angle, which I'm calling y. And I need to label the sides of this triangle in such a way that the secant of this angle is x. Well, secant is just the ratio between the hypotenuse and the adjacent, so the simplest thing to do would be to make that x and that 1. Now, it is true that the secant of y is x over 1, or x, and therefore this angle is arcsecant. If that's x and that's 1, then this is root x squared minus 1. And then I can go back over here, which was the whole point of this, was to simplify this. What's cosine y? Well, what is the cosine of y? I just look at my picture. Cosine of y is 1 over x, so there it is. And what is the cotan of y? It's 1 over root x squared minus 1. Okay. And this is, since x is positive, 1 over x will be positive, and we should expect the cosine of a first quadrant angle to be positive. And this is also positive, and we should expect the cotan of a first quadrant angle to be positive as well. So there it is. And so, the thing I wanted, cosine y, cotan y, is actually in this case just 1 over x root x squared minus 1. But when I try to do the same thing for the case when x is negative, I know that the arcsecant of something negative will be a second quadrant angle, so I call that y. But I need to once again label the sides of the triangle in such a way that the ratio between the hypotenuse and the adjacent is x. So if I try to just do x and 1, that doesn't work. Because, first of all, x is negative, so I can't have a negative hypotenuse. But also, it's just clear that in the second quadrant, my horizontal component should be negative, not positive. And so what we do is we just feel free to put negatives in front of both of those, and that solves both of our problems. Because now we can see that I did go left, and also that now if x is negative, then negative x is positive. Okay, so what I have done is I have labeled the sides of my triangle in such a way that the ratio, make sure this is still filming, yeah, that the ratio is x to 1. And you can just confirm, is the secant of y x? Is the secant of this angle x? Well, yeah, the secant of this angle is by definition the hypotenuse over the adjacent, and so you just get negative x over negative 1. That is x. So this is a picture of arc secant. Okay. Anyway, what is the horizontal, the vertical component? It's still root x squared minus 1. But now, when we go to compute cosine y, what do we get? Well, cosine y is it's negative 1 over negative x. That's 1 over x. And by the way, since x is negative, 1 over x will be negative. And so the cosine is negative. Do we expect the cosine of a second quadrant angle to be negative? Yes. So that indicates that we're doing this right. And what is the cotan of y? Well, the cotan of y is the adjacent over the opposite, I guess. So that's negative 1 over root x squared minus 1. And now examining this expression, we see that it's negative, but we expect the cotan of a second quadrant angle to be negative. So again, it means that we're doing it all right. Okay, and so the cosine of y times the cotan of y, which was the answer to our calculus problem, is in this case negative 1 over x root x squared minus 1. And this is kind of now like a drag, because this is right, but what it means is that when you have to just report what the derivative of arc secant is, you have to say that the answer is, it depends. It is, in fact, 1 over x root x squared minus 1 when x is positive, but it's 1 over negative x root x squared minus 1 when x is negative. And now, if you're smooth, and we are all smooth, you can write this more succinctly by noting that this is just the definition of the absolute value sort of in disguise. And so what almost everybody does is they say, in situations like this, when asked for the derivative of arc secant, we can answer more succinctly using absolute value. And so this is 1 over absolute value of x, root x squared minus 1. So that it's automatically positive, which, as we've seen graphically, the derivative of arc secant is always positive. Okay, this explains why arc secant has a absolute value in it, which is kind of a mysterious fact. Okay, good.